All right, thank you for having me, guys. I'm a very new transplant to LA. I was living in DC before I came here, so thank you for having me. As you can see on my t-shirt, I work at Tinder. We just released a huge new feature, Tinder Social, geared towards you want to go out tonight, you want to like pick your friends you're going out with. If you're in a relationship, you can now invite friends that are also not necessarily looking to go out to date people. So it's a really huge new feature we worked hard on, so please check that out if you get a chance. Like I said, I'm Andy. Twitter handle is @Andy Lawton. I'm the Android lead at Tinder. Before that, I was at Uber. I'm also responsible for PicLab and VidLab on iOS, if you guys have ever checked those apps out. So here is the link. I gave you, there's some nice code samples in here. They go along with the talk. And I'll provide the link to the actual slides to you afterwards. So I was told a few months ago that the MVP pattern was brought to you guys' attention. I don't know how many people were there or how many people are familiar with the pattern. It boils down to is really creating hard boundaries between your code. Really writing really loosely coupled code, right? That's always a good thing that we want to do. So I like to think of the MVP pattern as a big circle of data flow. So on the left-hand side, we have our views. In Android, this can be a fragment, an activity, or a subclass of view. And then we have these presenters, which take interactions from our views, and then they pass that into this model layer. Now, this pure MVP doesn't have interactors. Clean architecture, if you've heard of it, has these interactors. That could be a whole other topic of conversation. But basically what happens is, data starts here. Let's say a user on-clicks a button. The presenter is notified about it. We go to the model layer. The model layer comes back with some sort of data, and the presenter decides what to do with that. So it may tell the fragment to turn a button off. It may tell the fragment to leave, may navigate elsewhere. It doesn't care. It tells the view what to do. So the V in MVP, Android has multiple concepts of what could be a view. Like I said, we have activities. Go ahead.
Did you go backwards? So I've heard a lot about model view controller.
Yep.
How is
very similar. So really the biggest difference, model view controller, the models will often interact directly with the view. So the model will change something, and the view will get notified. Which is sort of bad because it's actually a big point I bring on later on the topic of we can inject view models into this point. So they're very much sibling design patterns. The presenter just really turns off the view from doing anything. With controllers, the view often does a lot of work. The view will have logic in it. But the MVP adopts what's called the passive view pattern, where the view does nothing. It forwards events and it gets told what to do by the presenter. So if you've used MVC before, this should feel pretty familiar. So like I said, Android has multiple concepts of views. We have fragments, activities, views, dialogues. And in a normal presenter pattern, presenter is presenting to a view or a fragment, whatever, and it knows about every single public method on that class. And that is bad, because then we can get ourselves into trouble. We can do stuff like get a context and cache it in the presenter, give ourselves memory leaks. We can update the UI directly. With that same context, I can inflate a view, add it to the hierarchy, do all sorts of crazy stuff. I could go ahead and get a loader from the activity or whatever. I can do all sorts of crazy stuff that is really violating this barrier that we set up. So who here is familiar with the solid principles of software, right? So Realm did a great series on solid. So there's SOLID, and the D in there is called dependency inversion principle. This is not dependency injection. That's a different topic. But the basis of dependency inversion is, here's like the super technical version, and this has never made sense to me. High-level modules should not depend on low-level modules. Both should depend on abstractions. But what this really means is, we want to depend on abstractions, not on concretions. It's bad that when we're presenting to a view, we know all this other stuff about a view that we don't care about, and we can get ourselves into trouble. So the way you do this is in Java really is you create interfaces that abstract certain behaviors and define the contracts between classes. So I've come up with over time working with this pattern is this target pattern, and basically it defines a relationship between a presenter and a view. It consists of methods that the presenter may call. It's just an interface with public methods. And then the activity or viewer fragment implements this method. So this interface. So what ends up happening is our presenter is now not presenting to a view or activity, it's presenting to this target. And the target has a very discrete API. So Pokemon Go is super hot right now. So so hot right now. So the sample code uses a Pokemon API that they have out there. Apparently it does existed for a while. It's also a terrible API. But so this is I'm going to go ahead and show you the UI so these methods make a little more sense. So super simple UI, right? Nothing crazy. We're hitting this endpoint, we're getting a certain Pokemon, we're loading a couple pictures of it, and then we're showing a list of its stats, right? Speed, whatever. So really all this view needs to know how to do is to show the Pokemon meta, which is like, Charizard's name and his shiny front and back, and also show a list of stats. And if there's an error, the UI is responsible for showing a dialogue, a toast, whatever. So we've very clearly defined everything that this view can do. Now this is actually an activity, but it wouldn't matter. We can make this a view, a dialogue, whatever, it will work. And then, so you see we have a Pokemon activity that I think implements this Pokemon target. So the target defines the method that a presenter may call, and the view is responsible for implementing these methods.
And the error is, show the error.
Yeah, so the error is basically, so the presenter, let's say that the presenter tries to go get some data from the database, or from the server, and the server's down.
Oh, yeah.
So they'll be like, okay, that happened. My job isn't to do anything with the UI. As a presenter, my job is to tell the UI to do something, and the UI handles that implementation detail.
And it's all the way across.
Yep. Yeah. It could be a static interclass of the presenter, but I prefer just to have a targets package. It could also be an interclass of the view or fragment it's hosting, but I think it's worthy enough of pulling itself out. Also, mocking it's a little bit easier when it's not a static interclass, but that's trivial. So here's the benefits. It satisfies the dependency inversion principle. I'm not worried about a concrete instance of a view or activity. I'm presenting to this abstraction. It prevents the developer from doing bad things. I cannot get a context with this. We cannot leak context into our presenters this way. Another great benefit, and this was really huge at Tinder Social, was if, let's say, like the design totally changes on a feature, but the basic backbone of it is the same, and it changes from a fragment into a dialogue. You don't have to change any business logic. Nothing changes on the presenter and business layer side. We only change the view side. So we get great decoupling. So what happened in Tinder Social was when you create groups and you search for your friends, it was originally an activity, got turned into a dialogue. The iOS team took like 4 days to do it. We did it in like 6 hours. So it was super awesome. A great point earlier was what's the difference between MVP and MVC. The passive view pattern on the MVP, meaning the view doesn't do anything unless it's told to. So this really hammers home that point. And here's a very clear API of what the view can do. Now the developer picks this up, they're going to see this view, they're going to see all these overrides, and they know exactly what this view can do. Obviously this takes, so we're now changed the concept of a presenter, so we're actually going to have to change the code in the presenter itself. So again, just to rehash, the presenter should not know the details of the view it's presenting to. That's a dependency inversion principle. It should only know enough to properly keep the view informed of data changes. So right-hand side, presenter and data. the presenter is listening to data changes, and it can intercept that and decide the correct thing to do to the view. The view should tell the presenter when it should be actively presenting. So what this means is, so Android has life cycle, right? Activities have on create, pause, resume, etc. On attached window, on detached window for views. So the presenter doesn't know like when the view is active. It has no way of knowing. So it is the view's responsibility to tell the presenter when it should be presenting something. So this is as simple as a presenter is. Presenter, it takes a type of T, which is the target. We're gonna do something really cool. We actually need the class type. We'll get into that in a second.
So get target.
Yep. So we'll have a get target method available in the full implementation. And then these two methods. And actually, let me do this backwards. So in an activity, on start, I'm telling this presenter to take the target, meaning start presenting. It's now time for us to be alive. And then when we stop, presenter drop target, we're saying now stop presenting to this thing. We're not interested in any more events. If a callback comes back, don't update the UI, don't crash, don't give us no pointer exceptions. And like if you're in a view, on detached your window, fragment, similar methods. So let's take a look at these two methods. These are both methods on the presenter. There's take target, which is simple. It's just a setter, and then drop target. And drop target does something really cool. So drop target. So drop target happens when Android's going away and we want to stop doing work. So what happens is we create a stub instance of this the target class. So the target class is just an interface with just public void methods. Super easy to do it via reflection, new instance. Takes no time at all. And then what happens is our presenter is now presenting to just a stub interface. So there's no hard reference to our activity, no hard reference to a context, and it'll get garbage collected quickly. So that means we prevent memory leaks. We don't have to worry about checking for null, like if our view equals null. And we just don't have to worry about, we can just have a sanity check of, we're never going to have no pointer errors, and we don't have to worry about crashing by something leaking memory. So just to go back, the view is responsible for telling the target, or telling the presenter when it should be presenting. The presenter, when it takes the target, it starts presenting. When you drop the target, it'll create a stub instance of that interface and put it as the actual thing it's presenting to. So like I said, so since this is just an interface created inside of the presenter, there's no outward references, so this thing gets garbage collected quickly, which is great because, go ahead.
Have you experimented with like weak references at all?
Sure. You could definitely optimize this here. The best thing to do, and you can use weak references, obviously, but since we are so explicitly doing this here, there really isn't a need for a weak reference. Because when I leave, I'm getting a stub instance of it. When I come back, I'm getting the real thing. So there's never really this point of we are totally removing the reference here of the activity, which is our view or whatever, which is the thing we don't want to hold on to. So a better implementation of this would be an annotation on the presenter. So we could eliminate, if you had an annotation, we could eliminate this step, and at compile time, we could generate all the targets. And that way we don't take the performance hit of doing reflection. So if somebody wants to write that, that'd be great. Cool. So all these benefits is no memory leaks and no null checks. It's super annoying. The presenter pattern will have to be if get view, if get fragment is added, making sure things are in the right state. The presenter is always in its presentable state, basically. One other thing, your view should always inject the presenter. There's a lot of implementations of the presenter pattern where, in the views, or activities on create or something, you will like create the presenter and pass it a reference to the activity. We don't want to do that for the reason we just discussed about. It violates dependency inversion, and we don't get the benefits of the drop in the target interface and the memory leaking. So the project has a fully set up Dagger implementation. I think it's a little out of the scope, like that could be a whole other talk, setting up Dagger. So if you're not familiar with Dagger, check the project out, and it will talk about things we do. So here's a fully fleshed out Pokemon presenter. I think we can see, can everybody see that? No? No? Okay. Let me see if I can zoom or something. Nope, zooming does absolutely nothing.
Try escaping out and then you can zoom.
Right.
Other way. There you go. And then maximize the window.
So why did it, when I got smaller, it got bigger? So the bigger, see, it's going to like, I'm at 300%,
Yeah,
but
you're zooming the outside.
It's an image.
Is it an image or is it a snippet?
it is a slide that has an image on it. I can just show you in code too, we can do that.
Yeah, let's do that.
Oh, there you go. Yeah. Could you open the site, the panel, so we can see our old package?
Sure. So normally I would follow feature, and then I would have each of these sub packages. So like, let's say the feature was called Pokedex. It would be Pokedex.activity, Pokedex.presenter. But for example, it didn't matter too much. So let's look at this Pokemon presenter. Come on, get bigger.
There is a presenter doing
Yeah, I'm in it right now.
Can you do like a two-finger expand on the touchpad to expand that increase the...
Oh no. Let me try one more thing. So I have it set up where a mouse plus command will grow. Alright, but I guess people can't really see this. So we'll go back to the slide. Alright, so I'm just going to talk about it basically. So Pokemon Presenter extends presenter. Pokemon target is the type of the presenter. We have notice it's injecting itself using constructor injection. I don't know if you can see that. You can't see that. And then there's just one method called load Pokemon, and then we're using RxJava to listen to, if on next we get a Pokemon, so we're calling getTarget.showPokemon and getTarget.showStats. And we'll see these methods bigger in a second. And then if the error case happens, we say getTarget show failed to load Pokemon error. So we never have to do any null checks, and we never have to care about the life cycle. Because the activity is doing that for us. Okay, so switch gears a little bit, but still related. Unit testing UI is super difficult, right? That's why I think like Roboelectric exists. But you don't really ever see people talk about patterns. People often say it's wrong to test your view classes, right? But it's oftentimes, it's like, where else does this stuff fit? So, and if you want to have really high test coverage, you can't ignore it. So the reason why it's difficult is we mix business logic with view logic. Like, we have the presenter side, which is acting with the business layer, but then like I may need an if or else statement if I need to do something very specific in the view, change a color in the view, things like that. And we have these business models, and they don't necessarily reflect like what we're rendering on our screen. So if you have this Pokemon object, it has this like sprites array, which is a list of images that I may want to show, but I don't know which one I want to show, and like it gives me too much information, whereas my view should be very explicitly being told like show this one. So who's familiar with the composition over inheritance? Right? So what this means is, sometimes when you're working with your business objects, you'll add like view related stuff to it. Like you'll add get display name when it's somebody, like a person, you want to show a person's full name. That's violating the business objects rule. You're now adding view logic and view behavior into your business objects. So what composition over inheritance does is you compose a new object that wraps the other object, and then you can add additional behavior without introducing an inheritance chain. So view models are a great way to do this. Let me see if I can actually show you. Let me just show you. So this Pokemon API, it has like a million fields, but we just care about a few. So we have a name, list of stats, and the sprites objects, which is a data structure that contains like 6 different types of pictures. So if I want to show, like, so and also like all the names that it returns are lowercase. So like Charizard, the C is lowercase c. So it's a really shitty API. But you would maybe be tempted to like add a method in here called like get display name, where you do add an uppercase for Charizard's name. But we would only do that. That violates the business rules and the view rules. So what we can do is create view models. So let's not get confused with the MVVM pattern, which is model view model pattern. Totally different thing. Who's familiar with MVVM? So we have view models doing work. They're broadcasting changes. This is literally a model that models what a view should look like. So it takes business objects, creates a discrete class that directly maps to what we're going to display on a screen. So, and these things are super testable because it's a very flat object, and using Makito, we can just verify that certain methods were called. So our Pokemon class, and then here's our Pokemon meta view model. So, like I said, when you get the name, the Pokemon's name isn't capitalized when we display. We want to do that, and I want to like show the front and the back of the Pokemon. I don't want to decide. I don't want the view to decide which one to show. I'm going to explicitly say, hey, do the shiny version of Charizard's front, and the shiny version's back. So when we like look back at the app, it's just this part right here. So capital Charizard and load these 2 images. Not very impressive, but let's keep going through the slides, and I'll show you why this was pretty cool. So again, going back to these layers, we have our view, we have our presenter, and then everything over here is our data layer. The presenter, the view, an event happens in the view, it talks to the presenter talks to the data layer, say, hey, I'm interested in something happening. The data layer comes full circle back, gives this data back to the presenter. But like I said, like sometimes the data we get back doesn't make sense to show in the view, right? That Pokemon object I got back like did not translate very well to like what I want to actually show on my UI. So your presenter can intercept, it'll spy on these data changes, and it can manipulate data and give the correct things to show to the view. And this plays hand in hand with the target, because in the target is saying, hey, I know how to show some view models, and it's just super dumb. The view doesn't have to know how to do anything really. So this is the blown up version of the onNext callback. So this is after we go to the API, we get a Pokemon back. We have the Pokemon meta view model, a static constructor called from Pokemon, and then we're saying get target show Pokemon meta, and that's all we need to do. And that'll like render the Charizard picture. Then we get a list of Pokemon stats, and we're going to create a list of stat item view models. So we loop through, create each one, and then we say get target show stats, and we get this nice, really clean item view model, which is modeling what the row looks like in a list view. So this is what the show Pokemon met. This is in the actual activity, and you see that this is super simple, stupid. Like the view doesn't need to know how to do anything. It just needs to know like, hey, I have some text views, I have some image views, and I'm gonna load them. So if you notice this is super testable, right? I can mock this, and I can verify that the correct method on my other mock gets called. So super easy to test coverage, and we actually have tests. I think the next slide is the test. Oh yeah, there we go. So the method we're testing is show Pokemon meta. We're mocking the Pokemon meta view model. We're returning a certain name when the get name gets called, and then we're just verifying that the name view call set text with the correct name. Boom, test coverage. Same thing with the Pokemon load images, telling it what sprites to return, and then it's verifying that the loader was called. So that's it. That's a lot. Who actually here like uses MVP in like projects now? Awesome. Have you guys like introduced any of these concepts or like targeting or view models? Yep.
Yeah, we use it. Sorry.
Yeah, I was just going to say, using from there's a code lab, Google Code Lab, that shows like a contract interface.
Yep.
And it has two sub interfaces in there. One's for UI, one's for, they called it like user actions, and basically like the presenter.
Yep.
So like you have two halves to the contract, and having whatever view, typically a fragment.
Yep.
Implement the UI interface and present it in the same way.
Yep. So there's a million ways to skin the cat,
Yeah.
but same principles.
Yeah.
Yep.
Yeah, I was just going to say that Victoria's we use MVP
Yep.
pretty extensively.
Perfect.
And you know, you have your targets, and we use, that's why I brought the weight references.
Yep.
We use that quite a bit, even for doing like callbacks.
Yep.
So the asynchronous call happens, and hey, our activity's gone, well, let it register for whatever.
Yep. And that's exactly what the target handles. So when I drop target and my callback comes back, it's like, hey, get target show, show the meta. Target's like, I'm just an interface. I'm not anything. I don't know what to do. I do nothing. And then we don't have any reference anything. So RxJava kind of killed this because like if you're using RxJava heavily, you just have subscriptions and you can unsubscribe. But it's still useful for stuff that isn't using RxJava.
Yeah, that was my next question, was like using the no logic pattern
Yep.
versus just unsubscribing to whatever it is that you're doing. So would you do that? Like if you're using RxJava, would you
Oh yeah.
rather just unsubscribe? And
100%. It's decorative, saying that I'm very clearly unsubscribing, because then you're never getting the callback. You're stopping the flow of the stream of RxJava.
maybe saving resources?
Exactly. Whereas this, it's like we're not getting null pointers, we're not leaking references, but we're still doing the work in the background. And actually, subscriptions don't necessarily stop the work in the background, but I just like the fact that it's very clear. Like I'm stopping, I'm not listening anymore. Or just sort of a safety net. Yeah.
One of the arguments I've heard against this kind of architecture is like, what about all the help you get from like Firebase UI or loaders or
Sure.
these other things that like marry these components together? It's like those are rapid development.
Sure, you can still use them. So to me, that's all data layer. So loaders are all data layer, and you can inject loaders. So like using like the repository pattern, which this example actually uses, I can still use a loader, and the repository is abstracting that, and they're still getting the same because it's all about, like I said, anything from this topic is boundaries, and so we still have our view boundary, presenter boundary, and let's say our data boundary is just using we're using async tasks to query the database, and we're like, that sucks, like let's use loaders. You're just changing the data layer, and everything else just magically works. So, yeah, and loaders are all, people should totally use, they don't use loaders enough. Free UI updates when data changes is awesome, so. Yeah, I like you.
One last question. I'll play devil's advocate on testing the UI.
Yep.
Like you've done such a good job of pulling out anything that we might get wrong out of the view. Why are you spending time testing it when you're testing it?
So that's just a philosophical debate, right? So who's here is familiar with Uncle Bob Martin, right? So we had this great article last year. It was like late 18th century, doctors never washed their hands, right? And the mortality rate of surgery was like 60, like 2/3 of the times you did surgery, you were going to die. So this dude started washing his hands, and his mortality rate went down really good, like 10% mortality rate. Nobody was like, well, that might make sense. Like, yeah, that sounds good to wash your hands, but I'm not going to do it. And he argues that in the future, we're going to look at unit testing the same way that people look at hand washing. It's like, oh my God, like you're not writing unit tests. But yeah, and views are like you can't test animations. You can't test. So we're just getting a little more test coverage, a little more security that a junior dev comes in and just turns something off or comments something out that they didn't think about. Just a little more security. And then so I actually gave a talk internally in Tinder that we had 800 increase in test coverage, right? That sounds phenomenal. But our test coverage was so low that 800% really wasn't anything that great. But it is like if you are interested in test coverage, like if you work at a spot where you need to have super high test coverage and your views just can't be tested, it's strategies to get yourself there.
Would you feel comfortable if you had, say, like a journey test through Espresso?
Yeah.
It basically like went through a happy path through the app. Would that give you confidence that
Yes.
this is redundant?
Yes.
Okay.
Yes and no. Yes and no.
You still want to test.
So here's the thing. How many of you have a good UI automation team? How many of you have a UI automation
You
team?
don't have a team.
Right? So that's not answering the question. The answer is, so you can actually combine with Jacopo, you can combine the instrumentation test and the unit test, and that'll give you the sum coverage. So yeah, I would feel fine. Like I would, if we had sufficient Espresso tests to cover this, then yeah, this is obsolete. Don't need to do it. It's testing for nothing. But in reality, so few teams have great UI automation teams. All the onus falls on the developers, and you already have to meet deadlines. You're not writing Espresso tests. But if you're a big shop and you have that, then yes, you're right. It's duplicate work.
I'm running Espresso test to test drive, like as an acceptance test to test drive out my feature.
Yep.
So it's a part of my development.
Excellent. Yeah, and I think that's the more correct answer, right? And I mean, because there's a reason why people kind of scoff, like, oh, UI test, like you're doing something wrong. It feels dirty a little bit. But if, like I said, you need high test coverage, like if that's a requirement, I like seeing high test coverage, to be honest, like just me personally. I like being like, yeah, we have 80% test coverage. But in practice, if you have those Espresso tests, you're good.
I guess for me, the other thing is, I've seen a number of times where I have like a whole body of unit tests.
Yep.
And we fire up the app and
It just doesn't work.
Right?
Yeah.
So it's like, great, all the units worked wonderfully. But
Yep.
like, so for me, like the Espresso stuff, like
Yep.
helps me
Sanity.
I wired it up well.
Yep.
Well, I mean, the UI stuff is good, but I think the biggest thing for MVP, at least for us, was being able to write unit tests for the presenter without having to worry about roboelectric for mocking and stuff.
Yep.
That's
Exactly.
arguably more important than worrying about UI tests.
100%. And you actually, the example I give, I don't use RoboElectric to do this UI test. You can mock sufficiently enough to avoid having to use RoboElectric. If you actually look at this bit of code right here somewhere, where is this code? This code will not be here. Oh, here it is. So you notice I have this like image loader. Like, this is another example of dependency inversion. I created this abstract, interface called image loader. Android Studio is like broken. I think this is in Chrome. Okay, so like literally nothing is working in Android Studio. I've never seen
Starting
it.
to validate captchas.
Man, I thought this was the new days. Remember Eclipse? You guys remember that?
Yes.
Clean, just clean it.
Just,
So if you notice, I have this image loader class, and all it is wrapping glide. And with dependency injection, we're injecting this image loader So let's say like in the future I wanted to like swap out Glide with Picasso or something. That's another example of dependency inversion. Don't go crazy with dependency inversion, by the way. You can make yourself some really awkward code. We actually had a hot internal debate about, in clean architecture with interactors, your interactors are setting your data boundary. Another layer, it's like a sub-layer between your data stores, network, whatever. And can we put Android system classes in the interactors? Like, can you put a telephony manager in there? I'm okay with it, right? But other people, you should add the dependency inversion there.
Manager directly or interface?
The manager directly. So my argument was you could use dependency injection to directly inject telephony manager, network manager, whatever. Other people's arguments were to provide dependency inversion to add that extra layer of not relying on a concretion. So these are the fun things we talk about in software. Like, these are the fun battles. So any more questions? Cool.